Alright, I forgot one thing that goes in between the output filter and the pass regulator, which is a ballast resistor. So we got in a ballast resistor. This is a 0.1 ohm, 200 watt thin film resistor. I don't know if this is going to be sufficient for this little guy. This is just a chunk that I had lying around. It's been cut off. You can see the hacksaw blade marks there. So he's going to connect to the positive rail. The positive will come up to him. He's got to be pretty tight in here because we got to fit the pass regulator right here. And I'm figuring that this is not going to be anywhere nearly sufficient for the pass regulator. And unfortunately, I just got my adapters that I'm going to use for the transistors, just like that. So unfortunately, I'm going to have to stop because these are like 30 bucks a piece and I want to do it right. I was going to cut it down and made it to this, but I could probably fit one more pass transistor here if I wanted to, and that'll lower the heat dissipated because the heat is going to be generated by these guys as they pass the current through them. So the more transistors I have in the pass assembly, the less heat's going to be dissipated, and the more safety factor will be involved. And I have plenty of these. I've got plenty of resistors, so it's not a cost issue here. It's a matter of heat. I want to keep the thermal rise within reason. And these guys, I could do the calculation, but I'm not going to be bothered to do it right now. These guys are rated at 85C, not 100C. After 85C, you have to start applying the derating per the data sheet. So we can only run this guy up to 85C without derating. So I don't know if this is enough to maintain 85C case temperature, but that's what this prototype is all about, is to get everything close to as final as possible. Run it hard, run it long, burn it in at 30 amps constant, and just let everything get really hot and see if we're going to be okay. I'm hoping it's going to be okay, because it's got to maintain 30 amp current density. That's the goal. That's its purpose. And then I'll have to go back and check the thermal rise on this and these guys and see if everybody's copacetic or not. Theoretically, you could attach all the power products to the heatsink that I'm going to buy, because it's going to be enormous. I think it's 4 inches. So this could, in theory, this could attach, instead of doing it this way, in theory I could probably attach it to the bottom of the heatsink, but I'll have to think about that. I'm not there yet. So these will be bolt-on. So whatever comes, these will bolt on. The transistors will mount to the top. The circuit board will come underneath, and then the legs will fit into turret terminals, which I'll swage into the board, because I've got thousands of turret terminals. So we're going to use those because I love using those. Each one of these transistors is only going to be passing like 4 amps. So they're not even going to really feel it, because these will handle 16 amps continuous. They don't mind. but the thing is we want to minimize the heat produced in the heatsink to keep it safe for the user and longevity. So I think unfortunately, I think this is probably it for today on this. We'll go ahead and mount this guy on the sidewall for now, and we'll wait for the big heat sink to come in to start looking at the assembly. It's really a bad way of doing things, but I would rather get everything in to plan it out instead of jumping ahead of myself. I'm jumping ahead of myself too much. So that's where we're at. Really not a lot to report. Sorry, but sometimes progress is slow.